All right, today, guys, we're going to talk about probability and kind of the basics of it. All right, let's get started. So first, here's your definition. So go ahead and pause it and write them down. So the probability is the likelihood that an event will occur. So the probability of A is just some event. The way that we can represent that is the number of ways A can happen. So the number of ways that it can happen over the total possible outcomes. Okay. So then sample space is a list of all the possible outcomes of an event. Go ahead and write these definitions down. All right, here's our rules. So first off, probability is going to be a number between 0 and 1. Okay, 0 means that it can't happen. 1 means that it's 100% that it's going to happen. The sum of all of our possible outcomes, so all the outcomes that we can have, if we added all the probabilities, it should equal 1 or should equal 100%. Okay, the probability of an event does not occur is the same as if I just did 1 minus by the probability that it will occur. Okay, and the last, but the probability of one event or another event occurring, so one or another, is equal to the sum, so we can add those up. We'll kind of discuss these later when we talk about mutual exclusive tomorrow. Now let's talk about sample space. Sample space is all the possible outcomes. So we write it as S equals, okay, and then all of the possible outcomes. So 1, 2, 3, 4, 5, and 6, because those are all the possible outcomes that I can get, okay, when I roll a dice. All right, tossing a coin, our sample space is, well, if you think when we toss a coin, our two choices are heads and tails. Those are the two outcomes I can get, okay? And score on a test, S equals, well, think if I get a test score, we can go from getting a 0 all the way to getting a 100%. And I use the dash there because it tells me that it can be anything in between. Because technically on our score, we could get like a 75.5%. So it's anything in between 0 and 100. Okay? So rolling two-sided die and adding their totals. So if we rolled 2 die and add their totals, well, our sample space would be, we can get a 2, a 3, and we can get all the way up to, if we add 6 plus 6 is 12. So I can't do a dash like I did on the last one because I can't get a 0.5 or I can't get a decimal. But so what we can do to kind of save some time is we can put dot, 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 and then go all the way up to 12. That tells me that I'm kind of following the pattern. You could even do 2, 3, 4, and then dot, 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 all the way up to 12. Okay. Now, sample space for day of a month that the birthday lands on. Sample space equals, well, we can have the first, the second, the third, and we can go all the way up until the 31st, because that's the highest one. Yeah, some of them have less, but I go all the way up to 31 because that's the most that they can have. Okay, and tossing 2 coins at once, well, we can, in our sample space, well, we can get heads and a heads, heads and a tails, the tails and a heads, and then 2 tails. So that's sample space. So sample space is just what are the possible outcomes. Now let's talk about finding the probability. So the probability is what we want over the total outcomes. So if we're going to roll a die, what's the probability of rolling a 3? Well, if I think a dice has a 1, a 2, a 3, a 4, a 5, and a 6, okay, so probability of throwing a 3, there's only 1 3 out of 6 possibilities. Okay, now rolling a odd number, well, 1, 3s, and 5s are odd, so that's 3 out of 6, which we can reduce to 1/2, which makes sense because half of them are odd, half of them are even. Okay, probability of someone being born in March. So if I think about this, that's March is 1 month out of the 12. So since there's 12 months, so it'd just be 1/12. Find the probabilities described below. So probability of rolling a 2 or an odd number. So the same thing if we look at the dice. We have a 1, 2, 3, 4, 5, and 6. You don't have to write these out. I'm just doing it for a visual. Well, a 2, and then an odd number. So I'm circling all the ones they could be. Well, if I look at that, that's 4 out of the 6 possibilities, which I can reduce to 2/3. Now, a spinner that is divided into 10 equal parts and numbered 0 through 9. Okay, so there's 10 spots in this spinner. Hey, what's the probability of the spinner landing on a number greater than 6? Well, ones that are greater than 6 are 7, 8, and 9. So 3 out of 10, since there was 10 spots on that spinner. And what's the probability of landing on a 9 or a number less than 3? Well, 9, and the numbers less than 3 are 2, 1, and 0. Okay? It didn't say less than or equal to, so I don't count 3. So that's 4 out of 10, which would then reduce to 2/5. So remember, it's just what we want over the total. Sometimes writing the numbers helps out. Okay, let's look at this one. So a bag contains 36 red blocks, 48 green blocks, 22 yellow blocks, and 19 purple blocks. You pick one block from the bag at random. Find the probability of each of them happening. So the first thing that I need to do is add them all up to see how many total blocks there are. So if I add up the red, the green, the yellow, the blue, purple, there's 125 blocks. Okay? So probably if I'm not yellow, well, you can either add up all the ones that aren't yellow over 125, or I'm just going to go ahead and do 125 minus those 22 yellow blocks. So I have 103 that are not yellow. Okay, and I can't reduce that, so that's my answer. Okay, probability of green, well, that would be 48 over 125. Okay, can't reduce that either. So that's my final answer. And then now red or purple. So there is 36 red blocks and 19 purple. So we're going to add the 36 plus 19. We're going to add those together to get the 55 over 125. So all I did there was I did the 36 plus 19 to get that 55. Well, then I can reduce those, divide them both by 5. So I have 25 over 11. All right, now this one's a little difficult to think about, but when we're rolling 2 dice and summing their total, so adding up what we get, okay? So for the sample space, when we went through it and it was 2 through 12, that's the answer. But when we look at this, I'm going to go ahead and draw kind of this table of what we can happen. I can roll a 1, a 2, a 3, a 4, a 5, and a 6. Over here, I can roll, on my other dice, I can roll a 1, a 2, a 3, a 4, a 5, and a 6. Okay? So if I roll a 1 and a 1, it's a 2. It could be a 3, a 4, a 5, a 6, a 7. Okay? Then I can roll a 3. 1 and a 2 is a 3. 2 and 2 is 4. 2 and a 3 is 5. Then 6, 7, 8. So I'm just going through all the totals that I could get. So these are all my possible outcomes. 9, 5, 6, 7. And then 6, 7. And last but not least, 7, 8, 9, 10, 11, 12. Those are all my possible outcomes, okay? This is going to come in handy in the next slide. So I made that table last slide to make all the possible outcomes that can happen if we roll the 2 dice and add them together. I put it in right up here so that you can kind of see it. Okay, so now let's go ahead and use that to help us find the probabilities. So there's actually probability of getting a 7. So look how many times we can actually get a 7. Okay, there's 6 chances for us to get a 7 out of, if I count all these up, there's 36 different possibilities. So 6 out of 36 is 1/6. Okay, now let's get greater than 5. So I'm going to go ahead and count up all the ones that are greater than 5. So I'm going to start with these 6s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So there's 26 out of 36. Okay, now we can reduce that, divide them both by 2, and we get 13 out of 18. Okay, can't reduce that anymore, so that is our probability. Now, probability of getting even, well, if we look at this, half of them are even, half of them are odd, so our chances are going to be 1/2. Okay, we could also just add them up. If I add them up, I end up getting 18 out of 36 are even, so that would just reduce to 1/2. All right, our X ticket. Your friend says that there are 3 events in a sample space. One event has a probability of 0.45. Second event has a probability of 0.39. Event 3 has a probability of 0.28. Is that possible? Explain. Well, the thing about probabilities is we know that they have to add up to 1 because they have to be that complete 100%. So let's add these up. 0.45 plus 0.39 plus 0.28. Okay, when we add those, we get 1.12. Okay, so that's 112%. Okay, that's above 1, so no, this is not possible. And the reason because, and you can go ahead and write it down when you explain, is because it's greater than 1, so it doesn't add up to 1.